Hello today, and welcome back to my YouTube channel. Today's topic will be on Latin square designs. This will probably be my last upload ever, but Latin square designs are an extremely helpful tool in statistics, mainly because they help with two-block factoring and the control of variables in a study you are doing. A key assumption of the Latin square designs is that the variables do not interact with each other, because if this principle is violated, then either inconclusive data will arise or the Latin square will just not work. And from this first example, it can be kind of hard to see it, but I have a better example, and that is the example of Sudoku. As you can see, in Sudoku, only one of each number from 1 through 9 can comprise a box, and only one of each number can comprise an entire row and column. This is not engineering related, but this is the most basic example and the most understandable example for everyday people to understand a Latin square design. Moving on to ANOVA use in Latin square design, you get your degrees of freedom, your sum of the squares for each treatment row, the columns, the error, and then the totals. Now, the F ratio at the end is one of the key variables to understand from a Latin square design, because this helps determine if you should reject your null hypothesis or if you should accept it. And this is based on how this is calculated is based on you take the mean squares of the treatments divided by the mean squares of the error. Now we have a real world example, and this is through agriculture. One of the main research points of Latin squares has been in agriculture, and whether it be soil gradients and how they move and distribute over a plot of land, or crops and fertilizers working with each other to see the best outcomes. Now, you're wondering how that relates to engineering, and for engineers, this can be extremely useful for industrial engineers, for example, because part of industrial engineering is optimization of resources, budgeting money to spend on resources, and if you know this, then you can spend less on soil, fertilizers, crops, labors, and you can even take it into things like water with fluid mechanics and how a sprinkler system should work over a certain area in order to maximize and optimize water usages. So in the end, it must be the money, right? Everybody loves a bit more money in their pockets. So thank you for watching. Have a good night.